Okay. 2011 scoring guideline, Form B, problem number 6. This is a no calculator problem. It shows a piecewise function with a graph of g that's defined from negative 2 pi to 4 pi, whose graph is given by the function f of x equals g of x minus cosine x over 2. And then it says find the integral from negative 2 pi to 4 pi of f of x dx. And it says show your work, show your computations that lead to your answer. Well, the first thing you should understand is if you're finding the integral of f of x, you plug that in. And we replace f of x with g of x minus cosine x over 2. We use our integral laws. We should see that we can write two limits here, I hope. And we can do the integral from negative 2 pi to 4 pi of g of x. And I brought the negative out and just went from negative 2 pi to 4 pi of cosine x over 2. The integral of g of x, this integral, is simply the area of this triangle. All right? So the base here is 6 pi. The height here is 2 pi.
We need a dx somewhere.
Oh, I'm sorry. Yeah, we should have a thank you. We should have a dx on the integral. You're right. My bad. All right.
So 3 pi.
And I probably should have the dx here on this one, but the point is, you're right, Luke. We should have the dx. But now, when I do this, we have to do the integral. Well, the area under the curve is easy. 1/2 6 pi 2 pi. Yeah, so it's just 6 pi squared. Yep. Now, the antiderivative of cosine x over 2. Well, I start thinking derivative of sine is cosine. And when I take this derivative, I'm going to get a half, so I have to have the coefficient of 2. So, and that's integrated from negative 2 pi, or evaluated from negative 2 pi to 4 pi. So, there is our statement. Okay, well now this gets really easy. It is 6 pi squared, just like you said, for the first term, minus, and then I have to do one term of this evaluation. And we put in 4 pi and negative 2 pi. 4 pi divided by 2 is 2 pi. Sine of 2 pi. 2 pi is 360 degrees.
It's 0.
It's 0. So we got 0, we got 0. All right, so we get 0 and 0. So we get 6 pi squared minus 0, which is just 6 pi squared. And that is the answer to letter A. There was 2 points on this. The antiderivative right here was a point, and the answer itself was a point. Okay? All right, so we'll group this, and we'll start problem B. And these are 2 points I think we just have to get. There's nothing hard about this problem. It just looks different, all right? It just put two skills together that we should know. Letter B says, find all x values in the open interval, negative 2 pi to 4 pi, for which f has a critical point. Okay. So what does that mean we have to do? Derivative. Well, first of all, we're going to have to we're going to set f of x prime equal to 0 for critical points. We should write that. Okay? So then, we should then know that f prime of x is equal to g prime of x. Derivative of cosine is negative sine. Do you guys agree? All right. Now, when we do this, well, we'll go back and score it later. So here's our derivative. And you want to know where this equals 0. Do we agree? So we want to set this whole thing equal to 0. And I'm going to write it this way. I'm going to write it as 1/2. All right? Now, do you guys agree there are 2 values for g prime? When we look at the graph right now, this is the graph of g. There are 2 values. There are 2 lines. this slope, you guys agree that I think the slope of this line is just 1. We should see that immediately. The slope of the other line is negative half. All right? So I would argue that we have a piecewise function. All right? So from negative 2 pi to 0 is going to be 1 plus, is going to be this function. 0 equals 1 plus a half sine x over 2. And then from 0 to 4 pi, the function is going to be this. Do you guys agree? And this is why we learned all of these trig functions in pre-calculus, all my pre-calculus students, because here we have two simple trig problems that we should solve like machines. Whatever Ms. Larson says makes it a classic. You get her to say yes, I don't agree.
Okay, well, what's a classic?
The Hobbit. All right, now.
Hobbit is a classic, but I'm not going to get into it.
All right, so I'm going to solve the first one. I'll call it A. And maybe I would actually label these. Maybe I wouldn't. If you guys agree, I would get 1/2 sine x over 2 equals negative 1. And this would be letter A. Multiply both sides by 2. I get sine x over 2 equals negative 2. Do you guys agree? What do you know about this? There is no answer. The range of sines, right? Remember our range. It's impossible. So there is no solution here. So between 0 and 2 pi, there is no critical points. Between negative 2 pi and 0, there are no critical points. If I do equation B over here, I move the half over, I get half. Sine x over 2 equals half. Divide both sides by half. I get sine x over 2 equals 1. All right. We know sine is 1 at pi over 2, at 90 degrees. So x equals pi. All right. So that is a critical point. So I think we need to know, do you guys agree? Now, what about 0? What happened? Is 0 going to be a critical point this time?
Slope is undefined.
Slope is undefined for G prime. Do you guys agree?
It goes from positive to negative.
And what's sine of 0? 0. So I think f prime of x doesn't exist at 0. You guys agree? So we got two of them. F prime of x does not exist at 0. And f prime of x equals 0 at x equals pi. So we have two critical points. So f has critical points at x equals 0 and pi. Remember, because critical points are not only when the derivative is 0, it's also when it's undefined. All right? If we were doing points, x equals 0 is a point, x equals pi is a point. That you got the derivative for g prime, that if 1 and negative half is a point, and that you took the derivative of cosine x over 2 and got 1/2 sine x over 2. There are 4 points there. Even if you got really, really confused, there should have been 2 easy points there. The derivative of sine x over 2 is an easy point, or cosine x over 2 is an easy point. And it's an easy point that x equals 0. That the derivative had to be undefined there because it's a point where the left hand and the right hand limits don't meet. Okay? They don't equal each other. All right, so let's do C. I'll group this. Letter C. Let h of x equals 0 to 3x of gt dt. Find h prime negative pi over 3. First thing we better do is take the derivative. Oh, and look, they gave us a 3x to make sure we know our rule. All right, so I think h prime of x is just g of 3x times 3. Right? You plug in the top. So that is worth 2 points.
Wow.
Holy cow, maybe I think you should get 6 on this all of a sudden. Now I get to see. There's 2 points. Now we just got to do the value. So now I do h prime of negative pi over 3 equals g of 3 times. And you guys notice this, what's going to happen? They don't expect you to know.
Negative 1 pi.
Yeah, it's going to become negative pi. They don't expect you to know a lot of your spots. 30, 60, 90, 45, 45, 90. You should know those, but they're sticking to the unit circle. All right? Everything's going to operate on the unit circle. We get 3g negative pi is the answer. All right? And if I go up to g here, and I look at negative pi, what value am I going to get? 1 pi. That's your 1 pi. The answer to this is 3 pi. And that's the point. And that is 2011, Form B, question 6, no calculator.